Now we come on to vector subtraction. Now by vector subtraction, what we mean is this basically. So I have a vector here A and I have another vector here B. So when I want to subtract them, what I do is I have to do an operation which is A minus B. Now see, when I write A minus B, I can put it as A plus of minus B. Now what I mean by A plus of minus B, I mean that the direction of B has been reversed. So mind you, when I put it as A minus B, what I do is I reverse the direction of B. Now what we mean by when we say that I am reversing the direction of B, you see, when I have a vector like this and another vector like this, and this is vector A and this is vector B, and I have reversed the direction of vector B like this, so it is minus B, and I know that I have to draw this parallelogram and get this resultant, so that is my A minus B. So you see what happens next is this angle, which was the angle between the two vectors as theta. Now the vector have these two angles between them, which is 180 minus theta. So when I am going to put it as a law, I should put it as r square is equal to, r means what? This resultant. R square is equal to what? It is equal to a square plus b square plus 2ab, and then I should put it as here. It is cos 180 minus theta. So as you all know, 180 minus theta comes to minus cos theta. So I am putting it like this. It is a square plus b square minus 2ab cos theta. So friends, you have to remember here one thing, that is case of the vector addition. When I am putting it, say, when I am saying that what is this? What is rp plus q? So you say rp plus q means I am putting the value of r as this, root over of p square plus q square plus 2pq cos theta. So you should know the symbol that rp plus q mathematically means this value of r. Similarly, when I am asking you to put what is r p minus q, then you should know that r p minus q means that r is equal to root over of p square plus q square minus 2pq cos theta. You can write it as simply as a formula as minus cos theta, or in that case, to be more sure, to be more, what would I say, correct as a student, you should put it like this, that it is r square which is equal to p square plus q square plus 2eq cos 180 minus theta. So that is more accurate, you can put it like that, and then you can go on to write it is p square plus q square minus 2pq cos theta. So the addition has a reversal in what we call subtraction. So I'll repeat again. Say if I have to subtract like this, a, b, and I reverse b. Similarly, when I am to subtract a from b, I can reverse b. So this gives us a very interesting situation, which we should now discuss. The situation is something like this. Say, for example, we are working with velocities. I have a velocity here, which is va, and again I have a velocity there, which is vb. Now, when I'm asked to find va minus vb, I reverse the direction of vb, and I get minus vb, and I get the resultant here by drawing the parallelogram and then taking the diagonal. Now, the diagonal, which is vr, the resultant velocity, is nothing but, as you can check it from this triangle law, is minus vb plus va. So this is va minus vb. So you see, this is va minus vb. Now when I am asked to find the opposite, that is b minus a, then what I do is I simply reverse a like that. So it is minus va now. And then I go on to construct the same parallelogram. And then I go to find out the same resultant. But you see, this time the resultant, as you can very clearly see from this figure, is minus va plus vb. So it is vb minus va. So as you can see that the resultant here is b minus a, and here is a minus b. So when you have to find out a minus b, you reverse the value of b, and when you are asked to find b minus a, you reverse the value of a. That is what we are fundamentally doing here. Now this particular write-up can be taken up VAB and this particular write-up as VBA. So now students, what we have learned just now is what we call this, relative velocity. So what we are doing here in a case of relative velocity is the fact that we are simply adding two situations and then we are subtracting again the two situations. Now in order to do so, what we are doing actually is here, as I can just show you for a small time here, is that when I have two velocities like this, one this and this other, when I subtract, I just take the reversal of the direction. When I subtract, I just take the reversal of the direction. So that is all we have. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.